Welcome to The Explainer. Today, we're going to pull back the curtain and peek into the magic of AI. I mean, you've probably talked to an AI, right? Asked it a question, maybe had it draft an email for you. But have you ever stopped to think, how did it actually learn to talk back? That's what we're digging into today. We're going to follow the entire journey of how a large language model, an LLM, goes from just a bunch of text to a seriously smart conversational partner. Okay, so let's start with the absolute basics. What is a language model really? Well, you might be surprised, but at its heart, it's just a prediction machine. Yeah, really. If you strip away all the fancy stuff, an LLM's main job is just to guess the next word. It's kind of like the autocomplete on your phone, but, on a completely different level. It sees a sentence like, the quick brown fox jumps over the, and its whole purpose in that moment is to figure out the most probable next word is lazy. And what's wild is that becoming incredibly good at this one simple task is what unlocks everything else, all the amazing things they can do. But how does it get so good at predicting? Well, like any student, it needs to learn from something. And its classroom, it's a gigantic, unimaginable library of text. And that text gets broken down into what you can think of as the Lego bricks of language. And I mean gigantic. We're talking about a digital library that makes any physical one look tiny. Basically, a huge chunk of the internet. Tons of books, articles, you name it. But here's the thing. Computers don't see words the way we do. So the very first step is to chop all that language up into pieces that a machine can actually work with. That process has a name. It's called tokenization. And it's exactly like breaking sentences down into those Lego bricks we mentioned. These little pieces, these tokens, can be whole words like running, or just parts of words like the eyeing, or even just a comma. And this is how it works. You take some plain old text like hello world. First, it gets broken up into those tokens we just talked about. But the computer still doesn't understand hello. So each unique token gets its own special number, its ID. And that's the language the machine gets. Because at the end of the day, for the computer, it's all just numbers. It's all math. Okay, so we have all these numbers. But how does the model learn that the number for queen is related to the numbers for king and woman? Well, the answer to that lies in a truly revolutionary piece of engineering that completely changed the game for AI. See, for a long time, models had to read text just like we do, one word at a time, in order. But that's really slow, and honestly, they had a terrible memory. They'd forget the beginning of a long sentence by the time they got to the end. But then, in 2017, this paper came out with a title that said it all. Attention is all you need. It introduced something called the transformer, and, well, everything changed. So what was so special about it? Instead of reading word by word, the transformer uses this brilliant mechanism called self-attention. It lets the model look at the entire sentence all at once. Think of it like a super smart highlighter. It can read a sentence like, the robot picked up the ball because it was heavy, and it instantly highlights the connection between it and ball, not robot. Understanding those connections across the whole text is the key, and it gives the model a much, much deeper understanding of context. All right, so we've got this incredible architecture, but an empty brain isn't very useful, right? So how do you actually teach it? It turns out it's a two-step process that takes the model from just being able to predict text to actually having a conversation with you. The first phase is called pre-training. This is where you just unleash the model on that massive internet library we talked about. Its only job? Get really, really good at predicting the next word. In doing that, it just sort of absorbs language. It learns grammar, facts about the world, even some reasoning. Then comes phase 2, fine-tuning. This is where we take that general knowledge and teach it to be a helpful assistant, using a much smaller, carefully curated dataset. Yeah, this fine-tuning part, this is really the secret sauce. It's what turns a powerful but kind of raw text prediction engine into the useful chatbot that you and I actually interact with. And one of the most popular ways to do this is a technique called reinforcement learning from human feedback. You'll hear it called RLHF. This step is absolutely critical. It's how we align the model with what we want it to do, to give answers that are actually helpful and safe. So how does RLHF actually work? Well, it's basically a 3-step process. First, you have real humans look at a bunch of different answers the AI gives to a question, and they rank them from best to worst. Then, you use all that ranking data to train a second model, called a reward model. Its only job is to learn what humans like. And finally, you go back to the original LLM and you fine-tune it with one goal: make the reward model happy. get the highest score possible. It really is like training a puppy. You give it a treat for the good answers, and it learns to do more of that. Okay, so we've been saying large language model this whole time. But what exactly makes it large? The answer is scale, and we're talking about scale on a level that's honestly hard to wrap your head around. These models have hundreds of billions, sometimes even over a trillion of what are called parameters. To put that in perspective, the human brain has around 86 billion neurons. Now, they're not the same thing, but it gives you a sense of the complexity. These parameters are like all the little knobs and dials inside the model's brain that get tweaked during training. The more knobs you have, the more intricate the patterns you can learn. And as you can probably guess, a model this huge is an absolute beast to train. You're not doing this on your laptop. As researchers have pointed out, you need thousands of specialized computer chips, GPUs, the same kind of thing used for high-end gaming, all working in perfect sync inside enormous data centers, just to get one of these things trained. But here's a really interesting challenge that comes with that massive scale. This chart shows that just throwing more and more computers at the problem doesn't always work perfectly. See, as you add more machines, they have to spend more time just talking to each other, which means you start to get diminishing returns on your power efficiency. So a huge part of the research in this field is just figuring out smarter ways to make this incredibly complex and expensive process run more efficiently. And there you have it. It all starts with a simple goal: predict the next word. You combine that with a game-changing architecture, a smart two-step training process, and you do it all at an absolutely massive scale. The result? A tool that doesn't just predict words, but can generate ideas, summarize documents, and even seems to reason. We literally just taught a machine to guess what comes next in a sentence, and somehow it learned to talk. It really makes you wonder, doesn't it? What's it going to learn next?